Let's go to solve these questions. They are conceptual questions for Newton's law. This question it says that a box is placed on a table which rests on the floor. Okay, this is the box, this is the floor. The box push on the box push on the table. The reaction force on the box push on the table is the table push of the floor, on the floor. Wow. Let's go to analyze what is the reaction. This is the mass. The mass is subject to two forces. Only two forces are subject. One is the weight, is the force where the earth is attracting him, and the other force is the force that the floor is doing on the mass. And the force that the force is doing on the mass is going up and is what we call the normal force. Then there are two forces, one up and one down. If these two forces are equal in magnitude, the acceleration will be zero. So, what is the reaction of the normal? This normal force is the force that the floor is doing on the object, so on the mass. So the reaction of the normal force, this is the floor, this is the reaction, and reaction. This is the reaction on the floor, meaning that is this force is the force that the mass is doing on the floor. So this is the reaction. While this force is the force that the floor is doing on the mass. So these are the two forces that are action and reaction. The action is the normal force, the force that the floor is doing on the mass. The reaction is the force that the mass is doing on the floor. This one is applied to the floor. The floor will accelerate it down by subject to this floor. Meanwhile, the mass little m will accelerate upward subject to this floor, to the force, subject to this force, to the force that the floor is doing on the object. Okay, this is the weight. This is the force that the earth is doing on the object. What is the reaction? The reaction is the force that the object of mass m is doing on the earth. And this force is going in this direction with the same magnitude. So the earth is being attracted by the mass m with a force that is this one, very small force compared to the big mass of the object, so will produce a very small acceleration on the earth. So the earth will accelerate with a very, very small acceleration due to the big mass. So now that I have said that, it's up to you to see if it's true or false. Let's to finalize the question. If this is the force that the mass is doing on the floor, this is the force that the mass is doing on the floor. The reaction is the force that the floor is doing on the mass, is this one. So here say push on the floor. What it has to be the floor. Let's go to do it well. I think that the problem is say like this. This is the table. Okay, it's making you too confused. This is the table. This is the floor. And this is the mass M. So the mass pushed the table. So the table received a force N. And the reaction is the force that the table is doing on the mass N up. N reaction, N action. So what has to be the floor? Nothing. So this is false. Okay, false. Because it say the floor doesn't have to be. The reaction, the box pushed on the table, the reaction force is the force that the table is doing on the box. And it doesn't say this. So this is false. Next question. General question. A girl attacks a rock on a string with its she then string counterclockwise in an horizontal circle. The string breaks at a point P. So this is the point P, the string, and it was attached. The 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 rock break at this point. So the object was coming at the point P. It was coming with this velocity V. And at this precise moment at the point P, the string break. So there is no force acting on the object. So the object will follow with the same magnitude of the velocity, because now there is no force, will follow this trajectory. So the trajectory will be the V. If there is no force, this is at the application of the first law of Newton. If there is no force acting on the object will stay with the same state, with the same vector velocity. The vector velocity will be the same one, the same magnitude, same magnitude, same magnitude as the initial magnitude, same direction, because there is no force. So the only possibility is that B is the correct answer. Please read this question carefully and answer. Okay, this question it say that as a rock is rotating in this direction, and at some moment at the point P, the string that was tied to the rock breaks. So the rock, which trajectory will follow? This one, this one, and this one, and this one, and this one. Well, this one means that after the breaking, there is force going in this direction. Otherwise, he cannot be make this curve. This one means that there is force going in this direction. This one means that there is force going in this direction. This one means that there is force going in this direction. But the reality is that there is no force going in this direction. So at the point P, when it arrived to the point P, the object was moving with V, with this vector velocity. After the string or the string breaks, there is no force, so the object will continue to move with the same velocity v. So this is the image. The v will not change, will never change, and so the only possibility is the b. The b is the correct one. Let's go to the next one. Okay, please read this question and try to answer. Okay, this question is more or less the same question of the old lady crossing the street and a truck is coming. The force that the truck is doing on the old lady is the same, is equal, is less than the force that the old lady is doing on the truck. And the force, the magnitude of the force that the truck is doing on the old lady is the same magnitude of force that the old lady is doing on the truck. Only the direction are different. So these questions, you can say I have two objects. I have the rope and I have the mass M. The rope for sure will have a little mass M. The force that the rope is doing on the mass M is going to this direction, while the force that the mass M is doing on the rope is applied to the rope and has the same magnitude in different directions. So now that I have said this, you try to answer if this is true or false. Let's go to the next question. Please read this question and try to answer. This question is the same idea. The action and the reaction happens, the action in object 1, the reaction is applied to object 2. So here we have two objects. One object is the rope. The other object is this rope. This rope. One object is the rope. The rope is acting on the mass M. So we isolate the mass M and we see that this is the force that the rope is doing on the mass M. This is the force acting on little m due to the rope. So what is the reaction? The reaction is on the rope. This is the rope. And the reaction is this force, is the force acting on the rope due to M, to the mass M. So this is so what it says. If the crater moves, the rope pulls on the crater must have been larger than the crater pull on the rope. But if the crater does not, the force that the object 1 is doing on the object 2 is the same magnitude but the opposite direction as the force that the object 2 is doing on the object 1. So this is false, okay? If I read it, but if the crater doesn't move, well, this is false, okay? There is no condition, but if the crater doesn't move, both of them must have been equal. Yeah, this is false. Sometimes these questions are tricky. You have to read it carefully. Let's go to the next question. Now, this question we discussed also in class and is not an easy question. The idea to solve this question is the following one. Wherever you see an object with acceleration, there is force in this direction. So, if I see the object with mass m accelerate in this direction, is because the total force, the total one, is in this direction. And the total force is the mass by the acceleration. And this acceleration is a vector. And this force is a vector. And the force follows the acceleration. But which force? The total force, the sum of all the forces. This symbol means the sum of all the forces. Sum, okay. Now you see this object. You see this object going like this of mass m, and of course this object is inside a plane. I think it's a plane, a train, what it say, while flying horizontally in an airplane. So this is inside an airplane. Let's go to make the picture of the airplane. So this is this is the airplane, more or less, okay? So inside the airplane, an observer is on, an inertial observer is here, is watching this, is watching a mass m with this angle. So is the plane accelerating in this direction or the plane is accelerating in this direction? This is the question. If you see this angle forward, is the plane accelerated in this to the right or to the left? So what is the analysis? The analysis is like this. You isolate the mass. So this is the floor of the plane, the floor of the plane. The floor of the plane is moving with the plane. Sorry, not the floor, the ceiling of the plane. The ceiling of the plane is moving with the plane. This is the mass m, and you see this like 15 degrees. So you will say, okay, I'm here, I'm the inertial observer, and you will say, what are the forces that are acting on the object? There are only two forces. Your conclusion will be like this. There are the weight going down, mg, and the tension going up. Now, if you see these two forces, the tension and the weight, what will be the sum? You don't see the object, the mass m, you don't see that go up. You don't see the object going downward, so the acceleration in the y direction is zero. That means that the component of the tension of the cable is equal to the magnitude of the weight. So the only survival of these two forces, the tension, so I have the tension, I have the weight, I have reduced my problem, the tension, the weight. I have reduced my problem to one equivalent problem, that is, I have the tension, some up and some going like this, and I have the weight, mg. So mg is in equilibrium with T. It has the same amount of forces going up by the tension Ty and Tx. So it has the same amount of tension going up that the weight. So the only force that remains, so the sum will be zero here. The only force that remains free to accelerate, is the tension. So because this object is inside of an airplane, the ceiling of the airplane is accelerating in this direction with this tension. This is the force that is acting on the mass m. So we can conclude that if this is the only force acting, this is the acceleration. So the object is subject to this acceleration. You can do the problem in the opposite way, in the case that this is the plane, no? This is the plane, okay? Okay, whatever is the plane, and you can do the problem. If you see this like this, what it will mean? It will mean that the plane is going to accelerate to this direction, A, in this case. So it's not easy to understand these things, but the general idea is you isolate the object. You see what are the forces that are acting on the object. And the sum of all the forces will be a vector. And the acceleration is in this direction, in the direction of the sum. If there is no acceleration in this direction, it's because there is no force. So if there is no force, it's because the acceleration is zero. And if the acceleration is zero, means that the object is moving with constant velocity. Let's go to question. The next question says, a bucket is being lowered very, very light rope with a constant downward velocity. So the velocity of the bucket is downward, and is constant. So this is exactly what I have said before. If the velocity is constant, the acceleration is zero. Wow. So the only way to produce zero acceleration, because the Newton's law says the sum of all the forces equal the mass by the acceleration. In this case, the sum of all the forces equals zero because the acceleration is zero. The only way to produce zero force is that the force is zero. So I need to have the same amount of force going up and the same amount of force going down. So this is the bucket. This is the rope. The rope is making a force going up, the tension. The weight is going down. So the only conclusion is that the tension, positive going up, if you choose this direction as a positive. If you choose this direction as a positive, the tension is positive, the weight is and T minus mg, the sum of all the forces is zero, so the tension should be equal to mg. So the conclusion is that equal to the weight of the bucket. This is the conclusion. Okay. And now we solve the next question. It says that you push a box G that is next to the box H, causing both boxes to slide along the floor as shown in the figure. The reaction force to your push. This is the force that you do on G. So the reaction is the force that G do on you. Okay. The reaction force is the force that G is doing on you. The push that G on the this is no. That G is doing on you. The push that G is doing against you. Yes, this one. The C is the correct answer. Please read this tricky problem and come back with the solution. It's tricky because I made a mistake during the class. I didn't read it carefully. I'm reading it now. Please try to solve it. Okay, the problem has two masses. The big mass is this one. The small mass is this the other one. So it's if you push to the left with this force, well, you produce an acceleration on all the two masses. What would be the acceleration? We don't worry now, but both mass will accelerate with the same acceleration. So M1 will be accelerating with A, the same acceleration like M2. Now, if you do this, on M1 will be a force acting, because if the mass M1 is being accelerated to the right, it's because there is a force. What is the force that is acting on M1? Is the force acting on 1 due to 2. Okay, this is the force. And the force acting on 1 due to 2 is the mass of the particle by the acceleration. Okay, because M1 is big, I expect this force to be big. Let's go to the other case. If you pull in the other direction, so now the force is being applied, the same magnitude of the force will produce acceleration in both objects. They are accelerating at the same rate, with the same acceleration, A. But in this case, the A will go to the right. So M2 and M1, they have the same acceleration. What happened to M2? On M2, we isolate M2. M2 is being accelerated, and what Newton's law say, if you see acceleration, there is a net force F on this direction, the same direction like the acceleration. And what is this force? This is the force acting on M2, and of course is due to the M1. So this is F21. But F21 is the force acting on 2 due to 1, is the mass M2, F2, the force acting on 2 is the mass M2, by the same acceleration in magnitude that in the first case. So what happened is that the magnitude of F12 is M1 by A, and the magnitude of F21 is M2 by A. But because M1 is bigger than M2, F12 is bigger than F21. And this is not, they are not the action and reaction that we look between them. The action and reaction, in this case, if I keep this problem, the action and the reaction will maintain the same and opposite side. If M2 will make a force on M1 in this direction, And there is a reaction of N1 on M2. Due to N1, there is a reaction, and these forces will be equal. But we are not comparing these two forces. We are comparing two forces that are not action in reaction. So the problem is very tricky. The answer is that larger if applied toward the left. If I apply toward the left, this F will be larger because N1 is bigger. It's a good problem to think that when you have an object of mass m and you see the acceleration in this direction, you have to see the amount of force that is m by a. If m is 2, you have to see 2 times a. If m is 3, you have to see more force, 3a. So I'm sorry that this problem is so tricky. Please read this question. Come back. Please read carefully and try to answer the question. So the questions say like this. They say you have two blocks, A and B. You can consider like one big block because they are moving together and they are moving under the action of a force that is 100 newtons. So if this is the only force, there is acceleration. But the problem say that the velocity is constant, so there is no acceleration. So what it means that? It means that there is 100 newtons to the right, should be 100 newtons to the left to produce zero force. And zero force produce zero acceleration. So the condition here is that the velocity is constant, the magnitude of the velocity is constant, so the acceleration is zero. So I have the mass. If I only have this force, I will have acceleration. The only way not to have acceleration is to have another force in the opposite direction that is in equilibrium. That's why they say equilibrium. It's the sum of the forces is zero. In a way, if that sum of the forces is zero, the acceleration is zero. So the correct answer is the A, where you can see 100 newtons to the right, 100 newtons to the left. This one cannot be possible because this is 200 newtons to the right, and 200 newtons to the right will produce acceleration to the right. So the acceleration would not be zero, so the velocity would not be constant. So this one cannot be. This one, for the same reason, a force that is going to the right will produce acceleration to the right, and the acceleration will be meaning that the velocity is not constant. So cannot be possible. For the same reason, this cannot be possible. And it say no horizontal forces acting on A. I don't know what it means. Stupid thing. Okay. So this is the answer. The answer is A. But I did a mistake, and the mistake is that I thought all the times that I was thinking on the two masses together. So I was thinking that the mass A and the mass V, sorry, I was thinking on the V. I think, so now I have to, what I said is completely true. So now let's go to think about the mass A, because I was thinking on the mass B. What happened to the mass A? The mass A is moving with constant velocity. So the mass A have acceleration zero. Oh, so the mass A, the sum of all the forces is the mass A by the acceleration. But the acceleration of the mass A is zero. So the sum of all the forces is zero. That is what it allowed to the body to have velocity constant, no acceleration, no total force. So this body is flying on the surface of B, and is flying, and nothing is moving the object A, the A. For the V, there is 100 newtons to the right, and the fact that the V is moving with constant velocity means that the 100 newtons to the left should be there. So the answer that the question is asking you is that what force maintain V constant? No force, no force, zero force, so no horizontal force acting on A. On A, sorry that I was thinking on B. Okay, read this problem and answer the question. Well, this is the reason why I don't like multiple options, but it makes you to confuse you a lot. Indeed, it makes me to confuse me a lot. So we have this pull P is 100 newtons. It doesn't matter the amount. We have this P. So this P here, there is a wire. So the wire, this is the wire, is acting on B. So this is the force on V due to the wire. What is the reaction? The reaction is the force on the wire due to the mass V, to the object V. So the action, the force, the initial for the 100 newtons go to the right, and the 100 newtons going to the left is applied to the wire. So the reaction is the pull that the box V does on the wire. The pull B does on the wire, the pull of the box B on the wire. This is the one that is correct. And sorry, they talk about the string, the wire. Maybe if I solve it in class, maybe I did a mistake. I don't remember. But this should be the correct answer. Check it in the system during the practice quiz. Okay, read this problem. It says this is a pulley. It has two mass. Little m is a small mass. Big M is a bigger mass, so we expect acceleration in this direction. The acceleration will go in this direction, so the change in velocity will go in the direction of the acceleration. It doesn't mean that the object is moving both of them. It means that the change in velocity is going up, so this is the change in velocity. V1, V2, okay, this is the change in the velocity. And for this object, the change in the velocity, if this is V, later on will be bigger, and the change in the velocity is A. The acceleration is here. So the object little m is accelerated in this direction, while the object capital M is accelerated in this direction. So when releases system accelerate and friction fluctuate. Which one of the following body diagram is most realistic represent the forces acting on the two objects? Okay, the object little m is accelerating in this. What it means this? It means that they have more forces going up than going downwards. Going downwards is the weight, mg, and going up is the tension, but the tension has to be very big because have to produce acceleration in this direction. M by A have to be, if M is 3, 1, 2, and 3. M by A doesn't have to be T. The force is T going up minus mg going down. This is ma. So the sum of all the forces is ma. So the acceleration is here, and T minus mg will be something, let's say that this is 10, tension 10, This is, let's say that the weight is 2 newtons. So I have acceleration upwards, and I will have how many newtons? 8 newtons going up. So 8, this amount of force will be 8 equal ma. So the acceleration will be the force, the 8 newtons divided by the mass. But the key question here is to understand that there is more tension, more force going up than force going down because there is the acceleration is going upward. So for little m, the picture is this one. For capital M is accelerating downwards. So it means that there are more force going downwards than upwards. So the weight, because it's capital M, very big weight, mg, will be very big, and the tension that is the same that this tension here, it corresponds to the same amount of tension, the tension will be the same one. But the weight mg will be bigger because we need more forces in this direction to produce acceleration in this direction. So the total force will be something like this, and this total force that will be the sum will produce acceleration in this direction. So now we have to choose which one it will be. Okay, in this one, for example, they have the weight small, the weight big, but the two tensions are not equal. And I need equal tension. So this one is not this. In this one, I have, this one look possible. I have the tension big, the acceleration is going upward because there is more force going up than downwards. But here the acceleration should be downwards. So this one, they look the same tension. Okay, so this one is this one. Okay, why not this one? Because I need the weight mg is smaller and I need the tension here for the mass. Why not this one? Because this one it say that the velocity is 0 because the tension and the weight are the same. And here the tension and the weight are the same. So the acceleration of the mass capital M will be 0, and here the acceleration will be 0. So the only possibility is the D, the only possibility. You see here that the acceleration is 0 because if you consider this mass have to accelerate upwards, so it needs to have more force upward than downwards. And this is not the case. I see more or less even, I see less force here, but in the case that is the same force upward and downwards, the acceleration will be 0 and the velocity will be 0, but this is not the case. The object is accelerating upwards. So, conclusion, D. D is the correct answer. Let's go. So read this problem and try to solve it. Okay, now the trick to solve this kind of problem is to interpret correctly the information that the problem is saying. First of all, the problem is saying that there is equilibrium. If there is equilibrium, the sum of all the forces are 0. So I need to have forces, the same amount of force going to the right that going to the left. Otherwise, there is not equilibrium. Also, I need to have the same amount of force going up that going down on the object. Otherwise, I will not have equilibrium. So, how we will solve this problem? The box rests on a resonance that has some friction on the box. Okay, the normal force on the box due to the floor. So it's asking, the problem is asking about the normal force. It's not asking about the friction force. So we know that the sum of all the forces are zero. So how we do this problem? So we imagine that this P can be can be can be treated like two forces. One is going to the right, the other one is going to the left, because this one plus this one, it will do the P. So I erase the P and I will work with this one and the vertical one and the horizontal. So this is the P now. This is the vector P. This is the angle theta. So this is P cosine of theta going downwards. And this is P sine of theta. Okay, so on the object, on the object, on the object, what are the forces acting? It is the weight, mg, the force that the earth is pulling down is the normal n going up, the force that the table is doing on the box that prevents the the the, the mass to fall, and there is the force P. But instead of treating the force P like P, I will say that there is P sine of theta going to the right, and I will say that is P sine of P cosine of theta going downwards. And the sum of all the forces is zero. So let's go to make the sum of all the forces in the x direction, and the sum have to be zero because there is no acceleration of the object. And let's go to write the equation for the sum of all the forces in the y direction, and should be zero because there is no acceleration in the y direction. What is the sum of the forces in the x direction on the body, on this body of mass m? On the x direction, I see. If you take the positive direction to the right, I see minus p sine of theta going to the left. So, to be in equilibrium, it needs a force. The friction force should be going to the right, positive, and the total force have to be zero. But so from here, you know what is the amount of friction force. The amount of friction force that you need to prevent P sine of theta to accelerate is the same amount to the right, P sine of theta. So, but this is not what it's asking. What it's asking is the sum of all the forces in the y-axis equals zero. This will give you an equation for the normal. What is the forces in the y direction? It's mg going downwards. This force P cosine of theta is going downwards also, and the normal force is going up. With this, I will create one equation. Let's say that I choose the positive direction going up. So the normal is positive, the weight is negative, and the P cosine of theta is negative, and the sum is zero. Why the sum is zero? Because there is no acceleration of the body going upward or downwards. AY is zero, M by AY. But because M is not zero, but AY is zero, the product will be zero. This produces an equation for the normal, so the normal will be bigger than in the case when the P doesn't exist. The normal will be now mg, if I solve from here, plus P cosine of theta. And this is the normal. So what is the solution here? The solution is mg, that is the weight, mg, the weight plus P cosine of theta, W plus P cosine of theta. So the solution is the P. Okay, check it, check it. Let's go to the next question. Okay, read this question and try to solve it. Okay, this question is a very similar question as we have solved before. I don't remember which number, but it's a very similar question. Now it's a train instead of an airplane. So this is the train, this is the train. And you observe in the train that the object is hanging not exactly on the vertical line. He's hanging through an angle theta. Mm. This is the angle theta that makes the reference. Okay. So the object is the train. So this is the ceiling of the train, of course. This is the same ceiling of the train. So you see this situation. Where is the observer? The observer has to be outside. The observer is on the station of the train. He's observing this. So he will say, okay, I see the mass M. I see the force tension T goes in this direction. And I see the weight mg. So now I will say, okay, in the y direction, there is no acceleration because it's hanging and it's suspended. It's like frozen in this situation. So in the y direction, there is no force. So that means that the tension has two components. So I will decompose the tension in two forces. This force, the one that is going up, this tension, I will put it here plus here. So this tension will be this force plus a little bit of this force. And this will be the tension T. The two forces that are acting are the tension and the weight. But I'm reducing the problem, I'm changing the problem, instead of two forces, the tension and the weight, to three forces. So this is the components Ty, and this is the component Tx of the tension. So what happened in this problem? The mass M doesn't fly up, doesn't fly down. So there is no acceleration. So Ty has to be equal to mg, or in other case, plus Ty going up minus mg going downwards should be 0 because the ay is 0. Okay, so the components Ty, that is t by sine of theta, this is Ty. Ty, if you see in the picture, is the magnitude of t by the sine of theta. So Ty is mg. But what happened with Tx? Tx is this tension, is the x component. So it exists Tx, and Tx will be the magnitude of t by cosine of theta. And Tx will be m, the mass, by the acceleration in the x direction. So what I'm applying is these two equations, the sum of all the forces in the y direction equal m by ay. The sum of all the forces in the x direction equal m by ax. In the first case, for the first equation, I'm saying that ay is 0. And in the second equation, I cannot say that ax is 0 because there is acceleration, because the object, this force cannot be cancelled, this force, Tx, cannot be cancelled. So Tx is m by ax. Now let's go to read what is asking the problem. What is asking? Tx is t cosine of theta. T, this angle is t. Tx is t cosine of theta. And t cosine of theta is m by ax. And what we say, which one of the following must be true about the tension T on the wire? Well, it's the component y that should be true. And the component y, the component x is also true, of course. Is our conclusion that Ty is mg, or the conclusion is that the magnitude of t by sine of theta is mg. This is the conclusion. And the y, let me see the angle. This is the angle. Is the same. This is the angle theta. This is the angle theta. So Tx is T cosine of theta. Ty is T sine of theta. So T sine of theta, this tension going up, T sine of theta should be equal to mg. Okay, T sine of, so should be the A. The A should be the truth, the correct answer. They give you to make you to confuse this angle theta. Normally the angle that we have deal with is theta like this. They make you to confuse you, but it doesn't make me to, the problem doesn't make me to confuse me, and for sure you will not be confused. So this is the correct answer. So as a summary, when you see a problem, what equation you will see, you will place for equilibrium or not equilibrium. You will say the sum. That's why you study a vector. The sum of all the forces in the x direction produce acceleration in the x direction. How much? The mass by the acceleration. The sum of all the forces in the y direction produce acceleration. How much? The mass by the acceleration ay. So this is the two equations that you will use always to solve Newton's problems in this course. Okay, let's go to the next one. Read the problem and come back. Okay, we have a person that the mass is 45 kilograms. So if he is stepping a scale, the scale will say, okay, if you stop in a scale, the scale will measure the normal force. And what is the normal force? You will say, well, there is a normal force going up, positive n, there is a weight mg going downwards, negative mg, and the total force is zero because the object, the guy of 45 kilograms, is not accelerating upward, it's not accelerating downwards. So because the acceleration is zero, the mass by the acceleration, the mass is not zero, the mass is 45, but multiplied by the acceleration zero will be zero. That will say that in a normal condition, normal condition and the normal force. But in a condition like this, the normal force will be equal to the weight, mg. So the weight is mg, and the normal force, it will be also 450. In this case, there is no problem. The weight equal to the normal force. Now, the problem is say, now the scale read 480 newtons. Which of the following Newton step on scaling an elevator? Okay, if he is scaling the elevator and the normal force is 480 Newton, what it means? It means that it goes up or it goes down. If the elevator is going up means accelerating up. It may be going downwards, but the acceleration is going up. The acceleration is up. It means that the velocity maybe was going downwards, but the velocity is decreasing, increasing, and this means that the acceleration is upwards. Okay, the acceleration is upward. So, not to make any more complication, let's say that the acceleration is upward, so it means that there are more force. The net force have to be in this direction. So what is the force acting on the object? The object is not the elevator, the object is the guy. On the guy, there is the weight and there is the normal force, it's the force that the floor of the elevator is doing on the guy. The normal force has to be bigger than the weight. Why have to be bigger than the weight? Because there is acceleration in this direction, and the sum of the two forces is equal mass by the acceleration, so the total force has to be upward also. So we apply Newton's law. The acceleration, we take it like positive going upward. The normal force, we take it like positive going downwards. The mg, we take it like negative. So the sum of all the forces equal the mass by the acceleration. And remember that the mass is always positive. So the sum of all the forces. So now we are doing the sum of all the forces in the y direction. So indeed, what we are doing is the sum of all the forces in the y direction is the mass by the acceleration in the y direction. Okay, what happened now? The sum of all the forces is the normal force going up minus the weight equal m by a. So the normal force is the weight plus something, and a is positive because m is positive and the acceleration is positive. So the normal now, a new reading is 480. The reading of mg is here, it's 450. So ma, the value of ma is 30. So the acceleration, you can know what is the acceleration of the guy. So 450, 480 minus 450, this is 30, equal ma, but m is 45, I think, 45 kilograms. So this is the acceleration to produce a change in 30 newtons in the normal force. Okay, and the problem is solved. And now let's go what is asking. Which of the following statement must be true? The elevator is accelerating downwards at constant rate. If it's accelerating downwards, the normal force will be smaller, have to be upward. The elevator is moving downwards at constant rate. So, no. So this is no, no. The elevator is accelerating upward at constant rate. Yes, it's accelerating upward at constant rate. The elevator is moving upward. The elevator is moving upward at constant rate. No, at constant rate means it's moving with constant velocity. Velocity is not zero. If the velocity is zero, the acceleration is zero, and the weight will be the same as the normal force. From the given, okay, so the result is the C. The elevator is accelerating upward at a constant acceleration means. Okay, and the acceleration, we found it, is this one. Okay, let's go to the next one. Read this problem. I hope that you know what is a bank curve. Is when the car is coming through here to you, to your eyes, and the bank curve, it allows you to take the curve with a lower risk. At higher velocity, you can take the curve. So, what happened? That this is the mass of the object. The object is subject to two forces. So the object will make a circular motion here. So this is the bank. Okay, this is the bank. You imagine in 3 dimensions the bank, and the object is moving in a circular motion. If you imagine in 3 dimensions the bank, you will realize that this is possible, and this is some road that built in a way to produce acceleration in the direction of here. Here, the acceleration will go to the center because it's a circular motion, it will go to the center. Okay, so what are the forces acting on the mass? On the mass, there is the weight, mg, going downwards, and the normal. There is any other force acting on the body? Oh, well, the floor is acting on the body, this is the normal. The earth is acting on the body, this is the weight. There is any other force? No, there is no more forces acting on them. So the sum of these two forces, N and mg, when you combine, how you will combine? You will say, instead of saying like this, you will say mg will go like this. Ny, the component ny will go like this. So it will be this projection, the ny, and the nx will be like this. And the nx, this is the object of mass m, and the nx will be like this. So the nx is the force going in this direction, So this force means that there is acceleration. So this is the force that produces the circular motion, because the ny is cancelled with the mg, because the object is not going up or down in the y direction. So there is no acceleration in the y direction. So ny minus mg is 0, because the sum of all the forces in the y direction is 0, because ay is 0. And through the x-axis, there is acceleration. The sum of all the forces through the x-axis will be the nx, and the nx will be the magnitude of n by this angle theta cosine of theta. Or let me see, this is the angle theta and sine of theta, because if this is the angle theta, the angle that the normal does with the vertical is this theta. So this theta will have n cosine of theta as the y component and n sine of theta as the x component of the normal. So the nx will be the magnitude of n by sine of theta. And this force is not balanced with any other force, so this force produces acceleration, and it's mass by acceleration. The acceleration is the acceleration of a circular motion, so it's v squared divided by r. So n sine of theta is n v squared divided by r. So what we have in this problem? We have, for one side, we have that the n cosine of theta is the mg, so the magnitude of n is mg divided by cosine of theta. And for the other side, that is the equation on the x direction, we have that the sum of all the forces in the x direction, n sine of theta, is mv squared divided by r. So if I introduce the value of the n, of the magnitude of n of this in this equation, I will have mg divided by cosine of theta multiplied by sine of theta is tangent of theta. Ng tangent of theta will be mv squared divided by r. The m will cancel, so the v squared will be rg tangent of theta. So as a conclusion to solve this problem, what is the force that produces the circular motion? The nx. The nx produces the circular motion. So let's go now to see what are the options that say here. It's the normal force from the road. Yes, the normal force from the road is the one, but it's the nx that produces the circular motion. What force causes the nx? No, it's not exactly the normal force, it's the nx. The gravity? No, the gravity is not. The friction force? No, here there is no friction. The things that why they build bank curbs is that even in the absence of friction, there is no friction, the car can take the curb with no risk at higher velocity. No need frictions in this problem. No force cast, no, this is no, so the only one that is valid is this, but maybe you have to say the nx is the one that produces the normal force in the x direction is the one that produces the circular motion. Okay, let's go. Please read the question and try to answer. So this is a different thing. Now the object is doing a curve. It's not a bank curve, it's a normal curve, and the object is not changing his velocity. So he has acceleration in this direction because he's doing like a circular motion. So it has acceleration, so it has force in this direction. And the force is the mass by the acceleration. Perfect. And the force follow the acceleration. Okay. So we know that the acceleration is going to the center because it's a circular motion. And we know that in a circular motion with constant velocity, we know that the acceleration is going to the center. Is going to the center. Okay, perfect. So now the question is, there is a force. Who is this force? Who is the force that is pushing the car to the inside of the curb? There must be a force acting on the object, on the car. Well, this force, the only one, is the friction force. The friction force is the one that is acting on the object and makes possible that the object will do the curve because there is force in this direction. So we'll do the curve. If there is no friction, the body, the car, will go directly moving in the rectilinear line. He cannot make the curve. Okay, so the correct answer is A, the friction force. Of course, the normal force is going up. This is no, the gravity is going downwards, but downwards the screen that you are saying, and upwards is the normal force going outward to your eyes. No force of this is the correct answer. Now, uniform circular motion. When an object moves in a uniform circular motion, the direction of the acceleration, well, the direction of the acceleration is always to the center. So the acceleration is always to the center. Always to the center is a circular motion, constant velocity in magnitude. Of course, in direction is not constant. And the acceleration is always to the center, and the magnitude of the acceleration is v squared divided by r. The direction of the acceleration is depend on the speed of the object. Well, depend on the speed of the object, the speed is not changing. So this is not a good answer. No, no. Is directed toward the center of the circular path. Yes, this is true. Is directed toward the center of the circular path. Yes, it's true. Is in the opposite direction of its velocity vector. No, no. The opposite direction of the vector velocity is like this, and the acceleration is going perpendicular. So this is no. Is directed away from the center. Is directed away? No, it's not away. It's inwards. In the same direction? No. So what is the correct answer here? No one. Let me see. Depend on the speed of the object. Well, hey, what the magnitude of the acceleration depend on the speed of the object is true, but it say the direction of its acceleration is. Well, this is wrong. It's going to the center with this magnitude. That's all. Is directed towards. Yeah. This is the correct answer. The V is directed. Okay. This is the correct answer. The V is directed toward the center of his circular path. This is the only correct answer. And the other one, no. Okay, let's go to the next one. Okay, read this problem and try to solve it. Okay, this problem says you have a block of mass m. This block of mass m is on the inclined plane. This is the inclined plane with the angle theta with the horizontal. Okay. What must be true about the normal force? The normal force, we always call it, instead of F, we call it N. So we maybe call it N also. N. The normal force is N. Okay. So it say the option is N is equal mg, N is equal mg sine of theta, or m is equal mg cosine of theta, etc. So the only question to answer the only thing to answer this question is to solve the problem. what are the forces acting on the body? There are two forces acting on the body. I see the weight mg going downwards, and I see the normal force. And the two forces produce acceleration in this direction, because the object is moving parallel to the surface. So the acceleration is here. So the total force have to be here. So what happened? So the mg, this angle, theta, is also this angle, theta. Trust me for the moment. So what will happen? I will put the x prime direction like this one, and the motion is taking place on the x prime direction. I will name the y prime direction. On the y prime direction, ay prime is 0. Because the body is not moving, it's not accelerating upward, it's not accelerating downwards. The body is going in this direction, in the x prime direction. So ax prime is different than 0. Okay, let's go now to apply Newton's law. We apply the sum of all the forces in the y prime direction equal the mass by the acceleration in the y prime direction. What is the sum of all the forces in the y prime direction? In the y prime direction, I see the normal force, and I see one of the components of the mg. So the equation will be going up, the normal force, going down, mg cosine of theta is going downwards in the y prime direction. And this is equal the mass by the acceleration a y prime. But I said that the acceleration is 0 because the body is not moving up to the y prime axis. It's always in the x prime axis. So the acceleration in the y prime axis is 0. So that will say that n is mg cosine of theta. Okay. Now let's go to doing the same thing with the sum of all the forces in the x prime direction. Is the mass by the acceleration in the x prime direction. What is the sum of the forces in the x prime direction? I only see n is not in the x prime direction, it's indeed in the perpendicular direction. So I see mg sine of theta. This force is what is in the x prime direction. So mg sine of theta is the force that is on the x prime direction. And this is equal to the mass by the acceleration in the x prime direction. So the acceleration that is falling down the body on the x prime direction, ax prime, is g sine of theta. So the two equations that are valid for this problem are these two equations. Now let's go to say what it says. It says the normal force is bigger than g. Wow. The normal force is bigger than g, the magnitude of the normal force. Let me think just a moment. No, the magnitude of mg has to be bigger to produce. So this is n going in this direction. And this is mg. If you have n bigger than mg, the sum will be like this. The sum will be n plus mg. If mg, so the sum will not be parallel to the plane, so the acceleration will not take place. So this is not valid. The normal force is mg sine of theta. So let's go to see if n is mg cosine of theta. No, it's not equal. It's this one. This is the correct answer. The C is correct. This is the correct answer. The n is mg cosine of theta. So this is the correct answer. The n is mg cosine of theta, and the other correct answer is that ax prime is g sine of theta. Okay, read the question and try to answer. It says you are standing in a moving bus facing forward when you suddenly slide forward as the bus comes to a medium stop. What force caused you to slide forward? Gravity? No, the gravity is downward. You cannot accelerate forward. The force due to friction when you on the floor of the bus, maybe there is no friction. Maybe there is a slight friction. No. The normal force due to your contact with the floor on the bus, no, the normal force is going up. It will not make acceleration to the right. There is no force acting, causing on you to slide forward. There is nothing acting on you. So the problem is like this. This is the bus. The bus is moving with velocity v. Suddenly, the bus is moving with a little velocity. It has a change, so he has an acceleration that is in this direction. In this direction is the acceleration, because the change in velocity is here. This is the change in velocity, and the acceleration follows the change in the velocity. So this has an acceleration. So here there is a guy. The guy, we can imagine that there is no friction with the floor of the bus. So this is the bus. So when the guy is moving at constant velocity v, the velocity of the bus, suddenly the bus decelerates or accelerate in the opposite direction of the velocity, and this guy will continue to move with the same velocity v. Oh, so he will maintain the same velocity because there is nothing acting on him. There is no friction on the floor. So the thing that makes him to move forward is the first law of Newton, that there is nothing acting on him, so he will not change his state. His state with velocity v, so the same v will be if the bus decelerates. Of course, this is if there is no friction, but indeed the friction doesn't play a big role in here. Okay, let's go to read this question. Say mass and weight. Mass is something that you have, you cannot change it. It's the sum of all the masses that you are made, electrons, protons, whatever. The weight is the force that the planet, the Earth of the Moon, is attracting you. It's the acceleration due to gravity is lower on the Moon than on the Earth. So if it's lower, your weight will be smaller. Which one of the following statements is true about the mass and weight of the astronaut? Well, the mass is the same and the weight is smaller. So I think it's the D. Okay, the mass is the same and the weight is less in the Moon. Okay. Okay, that's all. Let's